Hi, algebra students. Here's the key for the review in preparation for your quiz over 6.0 and 6.1. So let's start with number 1. We're simplifying exponent using exponent properties. Just remember that all of our answers have to be written with positive exponents. So make sure you're not leaving any negative exponents in your answers. For 6.1, so remember we want to group, so think like terms, group your coefficients together, group your powers of n together. Here we are multiplying powers with the same base. So we add our exponents, but remember you multiply your whole numbers. So it's 12n to the 7th power. Number 2, this time we have 3 factors, so I'm going to group the 5 and the 4 together. I have x cubed times x to the 4th, and then y. Oh, I actually have 5 factors. I didn't see a y and a z, so those cannot be combined. So you want to leave those separate. So 5 times 4 is 20. And then 4 plus 3 is 7, so it's x to the 7th power, y squared, and then z squared as well. All right, number 3, we're dividing 2 powers with the same base. Remember, with the coefficients, you want to think of those as a fraction. So it's almost like 2 separate parts again. So it's like 2/3 times m cubed over m squared. This fraction, unfortunately, cannot be simplified, so you're just going to leave that as it stands and not do anything with it. So we're going to leave the 2 in the numerator and the 3 in the denominator. When I'm dividing powers with the same base, I subtract my exponents. What I was thinking is cancel all of those m's that are in the numerator and denominator. So you have 3 m's in the numerator, 2 in the denominator. So that leaves you with 1 m in the numerator. So 2m over 3. You can also write that as 2/3 m, and it means the same thing. All right, let's take a look at number 4. For this one, again, think of the fractions separately, and then you have x squared over x to the 5th power. So I want to look at this a couple different ways. You can do 6 divided by 2 to simplify the fraction there, which is 3. And then we have x to the 2 minus 5, which is x to the negative 3. And then remember, this portion of the fraction has to go, this portion of the expression has to go in the denominator. In order to make a negative exponent positive, you have to push it down in there in the denominator. So it's 3 over x cubed. But I also just like to think of it like this. So I have 2 x's in the numerator. I have 5 in the denominator, so these are going to cancel, and there's my 3 x's left over. So remember, when in doubt, write it out. Number 5, you are raising a product to a power, so that exponent gets distributed to all of those factors on the inside. Remember, when you raise a power to a power, you multiply exponents. So x to the 3 times 2 and y to the 4 times 2. So let's simplify all of that, and that leaves us with 36. I don't know why my pen's not writing. 36, x to the 6th power, y to the 8th power. Okay, number 6, you can do a couple of different ways. You could distribute the exponent first. I think I'll approach it that way. So let's look at this. We've got 3 to the negative 3rd power, and then when you multiply negative 2 times negative 3, notice that gives you a positive 6. So you're going to move just the portion with the negative exponent is going to move down into the denominator. So it's this 3 cubed moves down here so the exponent can become positive. And then if you want, you can simplify 3 cubed as 27. So it's m to the 6th over 27 for your final answer. All right, so we got a couple things going on in number 7. The 4 is just going to stay right where it is in the numerator because we can't do anything with that. And then this m to the negative 2nd is going to move down in the denominator. So I'm going to just move that there, and there's no other m's to combine that with, so you just leave it. You could subtract exponents with your powers of n. But again, if you think about this logically, you have 2 n's in the numerator and 3 in the denominator. So if you cancel the extras, you just have 1 n left over there. So I'm going to clean this up so it looks a little bit more like a fraction. So it's 4 over m squared n. Number 8, we're raising, so this is a fraction raised to a power. So again, multiply your exponents. So in the numerator, z to the 3 times 2 is z to the 6th. And then y to the negative 3 times 2 is, whoops, that's a y, not a z. Let me fix that real quick. So that's y to the negative 6th. And because this has a negative exponent, it's got to move up there in the numerator. So everything's going to stay on the top. So my final answer for this one is y to the 6th power, z to the 6th power. You can write it over 1 if you want, but you certainly don't need to. All right, moving on, 9 and 10 are error analysis. So it says circle and correct the mistake. So it looks like this is a product being raised to a power. So the original looks like they're telling us they're going to distribute the exponent in step 2. So that looks correct. I think the error is right here, though. Instead of multiplying those 2 powers, they added, it looks like. So 5 cubed is 125, but it should be 125x to the 6th power instead of the 5th, because we multiply there. Number 10, circle and correct the mistake. Remember, flour equals power over, whoops, root. All right. Whoa, something crazy happened there. Let's get this fixed. I don't know what is going on with all that. Okay, I'm going to try this again. So, power over root. Okay, so my, let's see, my power's on the top, and it looks like that's exactly what they messed up. So these 2 are in the incorrect spot. So this is the mistake here. So it should be 4 squared and then the cubed root of that, okay? And I don't think they want you to, it doesn't say evaluate, it just says to fix it. So I think we're just going to leave it just like that, no evaluating, since we can't evaluate the cubed root of 16. All right, number 11, we are multiplying 2 powers with the same base, so we add our exponents. So it's 3/4 plus 1/4, which gives me 4/4, which is 1 whole. So it's just v to the 1st, or v. Number 12, so it says rewrite with rational exponents. So remember, x and y are not like bases, so you can't combine them. So you just really want to think about this almost as 2 separate parts. It's like saying the square root of x cubed and the square root of y to the 5th, okay? So when you rewrite that with your rational exponents, it's x to the, remember, it's the power over the root, so 3 over 2. And y to the 5 over 2, or 5/2. So x to the 3/2, y to the 5/2 is how that's going to look. Number 13, same thing. We're just evaluating, sorry, not evaluating, just rewriting this with a rational exponent. So v to the 7/4 is how that one's going to look, power over the root. Okay, it looks like we're going in the opposite direction with number 14. This time we want to go in radical form. So remember, start with your base. X is your base. Your power is m, so that goes on the inside. And your denominator is your root, so that goes on the outside. And then just as a reminder, remember you can also write that as the nth root of x raised to the power of m, like that with parentheses. So those both mean the same thing. All right, moving on to the second half of your review. Number 15, rewrite this one in radical form. Okay, so this has 2 separate parts. So we're going to do 3 to the, let's see, power over the root, and then times w. Ooh, I see what's happening here with this one. So hold on just a second. I'm going to scoot this over. You can do w to the 5/7. You can also just rewrite this as well, two different ways actually. 3 to the 5th times w to the 5th raised to the 7th root, or probably even easier, you can do 3w. Let me clean this up. Boop. Okay, so this would be the 7th root of 3w raised to the 5th root. Raised to the 5th power, sorry, the 7th root of 3w raised to the 5th power. So either this or this, either of those is fine. They both mean the same thing. Number 16 says evaluate and then simplify if possible. So we're going to again write this in radical form. So this is 64 cubed, and we're taking the square root of that. So again, you want to think about like what makes the most sense. And I'm looking at this one, and I think it's probably going to make the most sense to do the square root of 64 first and then cube it. So the square root of 64 is 8. And then we would do 8 cubed, which we can evaluate. If I go down here to my table, 8 cubed is 512. So that's my answer for this one. Same thing with number 17. Let's think about how we might, oh, I see what's happening with this one. This one appears like it might be confusing, but when I write this in exponential form, it's just 25 to the 3/3. And remember, 3/3 is just one whole. So it's just 25 to the first, which is just 25. That one's almost like so easy it's confusing. Number 18, we're doing the square root of 9 raised to the 4th power. Again, think order of operations here. The square root of 9 is 3. And so we're doing 3 to the 4th power. And if you look at your table there, that is 81. 3 to the 4th is 81. Okay, number 19, anything to the power of 1/3 means I'm just taking the 3rd root. So the 3rd root of 343, we can also call that the cubed root. So under x cubed, 343, looks like 7 is our answer there. Let's take a look at number 20. So this one in exponential form would be power over root, which again, it doesn't look like this is going to help me. So I might want to go back and think about evaluating that one a different way. So I'm going to start by doing the 4th root of 16 and see if that helps, and then cube it. So again, think order of operations. So if I go down to my table, the 4th root of 16 is 2. And then 2 cubed gives me 8. So remember, you have to kind of think outside the box with those and think about what makes the most sense, because some of these you can do them a couple of different ways. Number 21, let's see. So again, rather than write this in exponential form, which would give me 2/3, which doesn't help, I want to start by thinking about following order of operations. So inside the parentheses, it's asking me to evaluate the cubed root of 216. And in my table, I can see that the cubed root of 216 is 6. And then we're going to square that. 6 squared is 36. Evaluate and simplify 8 to the 2/3. So again, I'm going to try this in radical form. So we have the square, let's see, power over the root. Okay, so I think, again, parentheses are going to help me here. So I want to do the cubed root of 8, and then eventually we're going to square that. So the cubed root of 8 means what number multiplied by itself 3 times is 8, and I believe that is 2. And then 2 squared is 4. Excuse me. Okay, I'm on the home stretch. Hopefully I can call my cough and spell. The 6th root of 64 using my table is 2. And then 2 to the 4th power is 16. 27 to the 4/3. 27 is my base. I'm finding the cubed root of that and raising it to the fourth power. The cubed root of 27 is 3, and 3 to the fourth power is 81. Okay, and again, I'm doing all of this using that table in the lower left-hand corner. I'm not using a calculator at all. Okay, 25 is an error analysis. Let's see, circle and correct the mistake. So 49. Oh, I think what they're trying to do here is distribute the exponent, which you cannot distribute the exponent there and make that a 6. So that's the error. We can't distribute the exponent. Remember, the only thing we can do on this one is just take the square root of 49, which is 7, and then 7 cubed is, using again my table, 343. Okay, so no distributing exponents when we're working with radical form. Let's see, number 26. What do they want us to do here? Oh, times what? So we're working backwards. Okay, so 6m to the negative second n cubed times something equals 3m to the fourth n squared. Okay, so I want to think about what would I be multiplying by 6 by to get 3, and I believe that is the fraction 1/2, because half of 6 is 3. And then we have m to the negative second becomes m to the fourth. So that's m to the negative second. And then n. Ooh, that is false right there. Okay, remember I want to add. I'm adding exponents. That's my mistake there. So be careful. I have to add something to that. So what number added to negative 2 gives me positive 4, and I believe that's m to the 6th power. What number added to n cubed, what number added to 3 gives me positive 2, and that would be negative 1. So it's 1/2 m to the 6th n to the negative first. And then number 27, what number? The fourth root of what number to the fourth power gives me 16. Let's see here, friends. Oh, this is again almost a little tricky, so it's not as obvious as it looks, but I believe it's 16, because again, if you write that in exponential form, if you do the power over the root, 16 to the 4/4 is just 16 to the first power, which is 16. All right. So please take a look over all of that. You have a couple of review assignments tonight in preparation for your quiz, which will be on our next class period. So please email me if you have